Go.
Hello everyone, my name is David Rivera. I'm an electrical engineering student with the University of North Dakota. My lab partner is Clarissa Gonzalez. She is also an electrical engineering student. And our proposal is to convert a UAV using LabVIEW and a DMX controller for flight control. The background is, in 2003, a group of students from the University of Minho in Portugal created a UAV controlled by Bluetooth and Arduino technology. This was performed simply because they wanted to increase the flight range of the UAV. By doing so, they had to eliminate waste. Limiting the weight of the UAV increased the range, and therefore they accomplished their task. I am proposing that we further reduce the weight of the vehicle in order to increase the range much further, and also or increase the flight time. By using LabVIEW and the DMX slide controllers, we are basically looking at controlling a UAV and each of the servos and input and output ports in cooperation of electromagnetic devices necessary to convert a selected 8-bit code for proportional analog positioning in order to control the UAV flight controls. This is basically what we're doing is we'll slide that UAV DMX control to a position, and it'll output a code. That code would translate to a color. This disk is rotating at 1000 RPMs, and as the codes match, that 8-bit data signal is generated in order to control the peripheral that we are commanding. All the channels will look similar to this, with a break, a MAB, I know it's taking a long time. Ready?
Just pick up where you left off. Just pick up where you left off.
Yeah, okay. Ready?
Mm-hmm. Yeah, go.
The DMX protocol is a 1-bit equaling 4 microseconds, and its data rate is 250 kilobytes per second. We are using a break, which are levels from 0 to 250 kilobytes per second, and that controls the start of the signal and also the final sequence of the signal information. The mark at the break, the MAB, this is fucking making so much noise. You ready to start again?
Mm-hmm. Go.
The 8-bit signal is comprised of... No, let me start again. The 8-bit data signal for the DMX protocol is basically one bit equaling 4 microseconds at a data rate of 250 kilobytes per second. The frame consists of a break, which is levels 0 to 250 kilobytes per second, and it also starts the beginning and completes the final sequence of information within that code. Within the code, a mark after break, which is a MAB, signals that uses a break signal to god damn it. Okay, ready?
Mm-hmm.
The frame is consisting of 8 data bits. Each data bit has a least significant bit to a most significant bit. The data bits are comprised of a break, an MAB, which is a mark after break, an SC, which is a start code, an MTBF, which is a mark time between frames, a CD, which is a channel, data channel, comprising of the code. For fast system operations without a break, an MTBF. Okay.
Hold on. When you move your head back and forth,
Mm-hmm.
try not to be so jerky because I'm still leaning up against this
Well,
thing.
that's why I asked you not to do that.
But your computer's on your lap, which is also moving with you, so I'm not looking as bad, but it's just hard to keep it all straight, okay? Whenever you're ready.
The data frame is 44 microseconds long, consisting of 8 data bits, from the least significant bit to the most significant bit. The frame itself has a break, a MAB, which is a mark after break, an SC start code, MTBF, mark times between frames, a CD channel data, and then the last frame consisting of the end of the code. These codes are basically to control the servos within the UAV. Each servo has been designated for the ailerons, the flaps, also the rudder control, and elevators. The depiction is without splitters. The second depiction is with splitters, further reducing the weight of the aircraft and allowing increased range. The start of the code uses the value between 0 and 512 channels into a build array. This build array will eventually output into a command buffer to write the DMX code, which is virtually used as part of the Visa control. Visa is a LabVIEW control GPIB, serial USB, Ethernet, or PXI or VXI instrument, making the appropriate driver's calls depending on the type of instrument of communications. Basically, the Visa allows the command controls to output the signal of the strobes that are generated from your rotating disc. The communication of this light or the color signals can be transmitted using fiber optic cables, further reducing the weight by eliminating bundle wires of various sizes. To demonstrate the code for this UAV, I am going to open up LabVIEW. I'm going to select a continuous mode so I can vary the output. And as I vary the output and it updates the system, the command control continues to function as directed. Here's a channel selection of 134. The output command is 86. By further decreasing the slide for the DMX, as the system updates, the command updates to 55. The assignment of the codes is based off of what we wish to control using analog controls and technology. For example, engines 0 on off can be a designated color. Ailerons on off can be another color. Flaps another color. Engines and rotors and rudders all can be assigned different colors of the spectrum in order to fulfill flight needs. Here's the color codes for a basic DMX technology, which only has 56 codes. Each code can be designated by a group of frequencies or data bits. This concludes my period of instruction. Okay. Okay?
Well done.
Yeah. You're gonna hack it and